Welcome to a quick review of finding the area of 2D figures. So think rectangles, triangles, parallelograms, trapezoids, that kind of stuff. So have your note packet ready to go. We're going to go through and kind of remind ourselves of the formulas for some of these and then kind of how to put them to use. So first thing we need is some vocabulary up top. Perimeter is the distance around the outside of a shape. So think of going around the outside. Okay. Area is the amount of space inside of a shape. So instead of going around the outside, we want to fill that space on the inside. So area is going around the outside. Perimeter is going around the outside. Area is the amount of space inside. How much can fit inside of that shape? So a quick review of our formulas. So we talked about area of a rectangle before. Area is just equal to base times height. Sometimes we'll call it length times width, but it's basically the two measurements of your rectangle. A parallelogram, I always think of it as kind of like a rectangle that's kind of leaning over. So the opposite sides are still equal to each other, okay? But instead of right angles at the corners, it's leaning over a little bit. But to find the area of a parallelogram, you're still going to use base times height, okay? But here's where you want to make a little note. The height always meets the base at a right angle. So look for that little right angle symbol, okay? In a rectangle, it's nice because we know all those angles are already 90-degree angles. They're right angles. We don't have to care. But in a parallelogram, or what we're going to see here in a triangle, we always have to make sure we're finding the height, meaning that measurement straight up from the base at that right angle. And then last is a triangle. For a triangle, you're still going to do base times height, but base times height is the whole rectangle. Think of a triangle as just part of that rectangle. So we're going to throw in a divided by 2. So one way to think about a triangle is here's my triangle, it's really only half of that rectangle that goes around it. So we just want the area of just the triangle part. Well, that's only half of the bigger rectangle. So that's why we're always going to divide by 2. Okay. None of this should be new to us. It's all stuff we learned in 6th grade, but we might be a little rusty with it. So now let's put it to use. So one of the places some of us can struggle is when we're not given the measurements and we have to count them out. So on a grid like this first rectangle, don't think of it as dots. How many points do I hit? Think of how many line segments, how many chunks. So this one is going to be 1, 2, 3, 4 units long, and 1, 2, 3 units high. Okay. Whenever I don't tell you what the units are, you always just use the generic word units. For perimeter is just adding up all of your sides. So this one is 4, this one's also going to be 4, and if this one's 3, so is this one. Nice part of a rectangle is the opposite sides are equal to each other. And then we add 3 plus 4 plus 3 plus 4 is 24. Oh, not 24. Sorry, my brain is already thinking about adding. 3 plus 4 plus 3 plus 4 is 14 units long. For area, I'm going to ask for a little bit more work in area because that's where we're going to spend the most of our time. So for area, your first step is you're going to write out your formula. Area is equal to base times height. Now you're going to rewrite it and plug in the base and the height. So my base is 4. My height is 3. So 4 times 3. And then you're going to give me my area, including my units. Well, 4 times 3 is 12, but it's 12 squares. Area is literally how many squares could fit inside of that shape. So the units for area are always going to be squared, 12 units squared. But that's the work I need to see on each area problem. Write the formula, plug the numbers into the formula, and then give me the area, including the units. So for the next one, this is a parallelogram. So these dashed lines over here are not part of the actual shape, okay? So that 6 is just telling us how tall the shape is going to be, okay? but it's not actually part of the shape. The actual shape is 6.8 by 3. This side is going to be 6.8, and this side is going to be 3. So to find my perimeter, I'm going to do 6.8 plus 3 plus 6.8 plus 3. Do a little addition here. 1 plus 6 is 7, 10, 16, 19.6 centimeters. That's my perimeter, adding them all up. Now we're going to go to area, and this is where the formula comes in. So this is a parallelogram. Think of it as a rectangle that's leaning over. So I want to do base times height. Well, my base is 3. That's my flat bottom edge. But remember what we talked about earlier. The height is always at a right angle to the base. We don't want the slanted side. We want the height that goes straight up at a right angle. Well, that's my 6. So I go ahead and multiply. 3 times 6 is 18. My units are centimeters, so it's going to be centimeters squared. That's fine. All right, last one. All right, so our triangle. Again, triangles and parallelograms, you have to be extra careful to make sure you get the right measurements. So for perimeter, we want to go around the outside of the shape. So we're going to add 26 plus 26 plus 32, all of the edges of the shape. 12 isn't the edge of a shape, so we're not going to add up the 12. So 6 and 6 is 12, and 2 is 14. 1 and 2 is 3, 4, 5, 6, 7, 8. 84 feet. Now we go back for the area, and these are the ones I really want you to focus on today. So for area, the formula for the area of a triangle is base times height. But remember, it's only a triangle. It's not the whole rectangle, okay? So we have to throw in that divided by 2. But always write out that formula, refer back to those notes, okay? It'll keep you from missing some of that. So my base is always that flat bottom edge, 32. My height, remember, we don't want those slanted sides. We always want to look for that right angle that goes straight up. Sometimes it's in the middle of the shape, okay? Sometimes it's on the corner of the shape. Sometimes it's outside of the shape, but we look for that right angle to know that it's going to be my height. In this case, my height is 12, and I want to divide by 2 because it's a triangle. So this one I'll break out my calculator. 32 times 12 divided by 2 gives me 192. Since I'm dealing in feet, it's going to be feet squared. So units for area are always squared because I'm literally figuring out how many squares, how many little 1 by 1 squares could I fit inside of that shape. But again, make sure formula, numbers in the formula, answer with your units. All right, flip to the back of the page, skip over the trapezoids up at the top of the page, and I just want to come down to this one down here. We're going to save this one over here for tomorrow. So sometimes we have something called a composite figure. Okay, think of it as it's kind of an ugly shape, and we're going to break it down into smaller shapes in order to be able to find its area. So for this first one here, think of it as if we were to slice this shape off here. I have a rectangle and a triangle. So for each one of them, we're going to go ahead and find its area, and then we're going to put those pieces back together when we're done. So for my rectangle, it's 6 meters by 10 meters. So my formula for the area of a rectangle is base times height. My base is 10, my height is 6. 10 times 6 is 60. I'm dealing in meters, so it's meters squared. Now for the triangle part. You'll notice that each time I do this, I draw out the shape so I can make sure I put the right measurements in the right spots. So on this one, I know that my height is 7 meters, but I need this base. Notice I want the ones that meet at the right angle. Well, This edge here is the same as this edge here, so it's going to be 6 meters. Now I go ahead and find my area. Well, it's a triangle, so base times height divided by 2. My base is 6. My height, that measurement going up at a right angle, is 7. I'm going to divide by 2. So write your formula, plug the numbers into the formula, and then go ahead and solve it. 6 times 7 is 42. Divided by 2 is 21 meters squared. And then our last step is we broke this composite figure down into smaller pieces. We found the areas of each of them. Now we put those two pieces back together. 60 plus 21 is 81 meters squared. That's the area of that entire shape. All right. Hope that helps. Now it's time to practice.